Hello, welcome back. Today we are going to talk about partial fraction. We are going to use partial fraction decomposition to integrate some integrally today, okay? So partial fraction. So first thing you can see, we have one fraction here, right? One rational function. So there's a method of partial fraction. The method of partial fraction will break it down to a multiple fractions. One fraction to two fractions. So you see these two term is equal. This two term is equal. If you can see, if you decide to write this one as one term, combining them, you will get exactly the left one. That's what partial fraction mean. So now you can see this integral is difficult to integrate, but this is easy to integrate. This term is difficult to integrate, and this one is easy to integrate because I will just apply ln, and I will get this integral. So that's the use of partial fraction. Sometimes if you have a difficult fractions, you check if it's not an improper fraction, you just try to break it down to two or multiple fractions so you can integrate. So first thing, the linear factors, simple linear factors. Procedure for partial fraction with simple linear factors. So you follow these steps, okay? Suppose f of x is equal to px divided by qx, where p and q are polynomial with no common factors, and with the degree of p less than the degree of q. That's most important. Assume that q is the product of simple linear factor. The partial fraction decomposition is obtained as follows. Step 1, factor the denominator q in the form of x minus r1 times x minus r2 and so on, where r1 to rn are real numbers. So those r1 to rn are what? The zero of q. Okay, you break down q into linear factors, and then step 2, partial fraction decomposition. Now form a partial fraction decomposition by writing your px divided by qx as a1 divided by x minus r1 plus a2 divided by x minus r2 plus so on up to an divided by x minus rn. And then step 3, clear the denominator, multiply both sides of the equation in step 2 by qx. So you just clear the denominator. Okay, or you can just clear the denominator. So that means what? Have this common denominator on the right side so you can clear the denominator. So which produce the condition for a1 to a sub n. And then step 4, solve for the coefficient equal. So what do you mean? You just set equal term that are equal. So you look at the power, you compare the x power and the coefficient. So equate like powers of x in step 3 to solve for the undetermined coefficient a1 to a sub n. There is also a shortcut which I will show you at the end. So let's go ahead and do this example. So in this example, we are asked to find the partial fraction decomposition of f of x is equal to 3x squared plus 7x minus 2 divided by x cubed minus x squared minus 2x. And then step B, we will evaluate the integral f of x dx. So solution. So first thing, we will start with step 1, okay? So let me write my solution. So step 1, we have to factor the denominator, right? You don't need to write the steps, but I'm just following the steps that I gave it to you. Step 1, we are going to Factor the denominator. The denominator is what? X cubed minus x squared minus 2x. We have three terms, all three terms are multiplied by x. So first thing I will factor x, then I will have what? X squared minus x minus 2. And x squared minus x minus 2, if I factor that, the factor form will be x times x plus 1 times x minus 2. So how many factors do we have? We have 3. So then now we move to step 2. All of this is linear, right? And then step 2, we'll write our equation, our fraction, which is 3x squared plus f 7x minus 2. So 3x squared plus 7x minus 2 divided by the denominator, which is x cubed minus x squared minus 2x. Or should I put the factor form? Let me put the factor form. I don't need to put this one. Let me just put, because we already factor, we know the factor form is what? X times x plus 1 times x minus 2 should be equal to, since we have 3 factors, so I will have a divided by x plus b divided by x plus 1 plus c divided by x minus 2, because we have 3 factors. So each factor will have, I don't need to use a1, a2, a3, because we can use a, b, c in this case. Now, the goal is to find the undetermined coefficient a, b, and c, okay? Which means we'll move to step 3 now. We multiply both sides of equation in step 3. We multiply both sides of equation in step 2, obtained in step 2 by the denominator, which is the denominator of the function was what? X times x plus 1 times x minus 2. So we'll multiply both sides by that. By doing so, what we are going to do, we said we'll multiply both sides by x times x plus 1 times x minus 2. So times what? Times 3x squared plus 7x minus 2 divided by x times x plus 1 times x minus 2 should be equal to, multiply the right side also by x times x plus 1 times x minus 2 times a divided by x plus b divided by x plus 1 plus c divided by x minus 2. So by doing so, we can see this and the denominator will cancel out. So it will left what? 3x squared plus 7x minus 2 should be equal to, if I distribute this one inside, for the first fraction inside the parenthesis, x and the denominator of that x will cancel out. So we will be left with a times x plus 1 times x minus 2 plus b times x plus 1, and x plus 1 will cancel out. So it will left x times x minus 2 plus c x minus 2 and x minus 2 will simplify. So it will be c times x plus 1. So we keep the lefts as it is. We don't touch that, right? Even if you want, you don't need to keep writing it until you distribute and try to combine like terms. So if I distribute these parentheses, right? X plus 1 times x minus 2, that will give me x squared minus x minus 2. If I distribute bx, it will give me what? Bx squared minus 2bx. If I distribute cx, it will give me cx squared plus cx. So now, I'm not done yet. My 3x squared plus 7x minus 2 should be equal to what? So you will see we'll have ax squared, right? We'll have ax squared here. So we have bx squared, we have cx squared. So if I factor x squared, I will have what? A plus b plus c, right? Then plus, if I distribute a, I will have negative ax. So in here, I will factor x plus x factor. We will have negative a. We have negative 2b. We have plus c, right? And then we'll have a times negative 2. So we'll have negative 2a as well. Okay? So now we will compare the degree of the left side and the degree of x on the left side and the degree of the right side, which is step 4, right? Step 4, we now equate coefficient of x squared, x to the power of 1, and the constant is considered what? Like x to the power of 0, which is 2a on both sides. The equation in step 3. So by doing that, we can see we have 3x squared, right? We have 3x squared is equal to x squared times a plus b plus c, right? So which means a plus b plus c will be equal to 3. And then we have 7 times x, right? Which will be equal to negative a minus 2b plus c times x. So negative a minus 2b plus c should be equal to 7. And then finally, we have negative 2 should be equal to negative 2a. So now we have what? Three linear equation with three variable, right? You know how to solve this one. You can solve it using substitution elimination. It's up to you how you will solve this one now. But you need to know how to solve. Some people can use their calculators, type as a matrix, and then solve it easily. But of course, by looking at this one, the third equation is easy to solve. The third one, we can see A will be equal to 1. So since A is 1, we can substitute A is 1 in the other two equations. So if A is 1, we will have what? 1 plus, or let me write in equation 1, since because in 1 and 2. So we will have what? 1 for equation 1, we'll have 1 plus b plus c is equal to 3, which means b plus c should be equal to 2. And in equation 2, we will have negative 1 minus 2b plus c is equal to 7, which means negative 2b plus c should be equal to 8. So we have two linear equations to solve. As I said, you can use any method you want. Now we can solve b plus c is equal to 2, negative 2b plus c is equal to 8. So I can solve by multiplying this by negative 1. So we'll have 3b should be equal to negative 6, which means b will be equal to negative 2. And if b is negative 2, then c also will be what? C will be negative 4. As I said, it's not in this calculus 2, you will learn how to solve a system of linear equation. That's what we have. So solve it as is easier for you. So we have our ABC now. We can said our f of x can be written, the fraction decomposition of f of x will be a is 1, so 1 divided by x. B is negative, so minus b divided by x plus 1. C is 4, so plus 4 divided by x minus 2. So that is the linear, sorry, that is the partial fraction decomposition. So B now, we are going to integrate. So to integrate, the original integration was what? 3x squared plus 7x minus 2 divided by x cubed minus x squared minus 2x dx. We have to find the partial fraction, which would be finding the integral of 1 divided by x minus, why did I put b here? It's 2 minus 2 divided by x plus 1 plus 4 divided by x minus 2 dx. And then we know the antiderivative of each of these terms is what? ln. So I will have ln of absolute value of x minus 2 ln of absolute value of x plus 1 plus 4 absolute value of ln of absolute value of ln of absolute value of x minus 2 plus c. And that's it. So if you want, you can use the properties of ln to condense this term. So which will be ln absolute value of x. You move the 4 to the power 4 is even, so this will always be positive. So times x minus 2 to the power of 4 divided by this also is positive, divided by x plus 1 square. So both is the same, okay? You can leave it like this or like this. So next, we have repeated linear factor as well. So sometimes the same linear you can have the same factor multiple times. That is called linear of repeated linear factors. But before that, let me tell you something. So I said I will show you the shortcut how to find your A, B, C. If to find your A, B, C without doing the system of linear equation. Yes. So like since this step, since right here, you see, since right here, I'm going to copy this part, which is we had when we were trying to cancel the denominator, we had 3x squared plus 7x minus 2 is equal to what? A times x plus 1 times x minus 2 plus bx times x minus 2 plus cx times x plus 1, right? So the easiest way is, because this equation hold for all value of x, it must hold for any particular value of x as well. So like if x is 1, x is 2, x is 3, x is negative 1, x is 4, x is... So it should be true for all of them because it's an equation. If you substitute any x value, it should be true for all of them. So it is easy to solve for a, b, c. For example, if we set x is equal to 0, we'll see the left side of the equation will be what? Just -2, right? And you will see we said x is 0. So if x is 0, we'll have 0 plus 1, which is 1. 0 minus 2, which is -2. So -2 times 1 is -2. So we'll have -2a, right? Uh, Plus bx, x is 0. So 0 times anything will become 0. This one also will be 0. So from there, we can see, we can set what? A will be 1. Also, if we set, because again, if we set the equation x is equal to -1, why? Because we know -1 is a 0 of the denominator. You see, if we set x is -1, we'll have -1 squared, which is 1. 1 times 3 is 3. And 3 minus 7 will be -4. -4 minus 2 will be -6, right? So we'll have -6 will be equal to, and on the right side, x is -1. -1 plus 1 is 0. So 0 times anything will be 0. 0 times a will be 0. On b, we'll have negative b. -1 minus 2 is -3. So -3 times -b is +3. So we'll have 3b, from which we will see b will be equal to -2. And then once we set x is equal to 2 as well, you will see 2 squared is 4. 4 times 3 is 12. 7 times 2 is 14. 14 plus 12 is 26. 26 minus 2 is 24. And then we will see a will become, we will have a 2 plus 1 is 3, but 3 times 0 is 0, times a is 0. 2 minus 2 is 0, times bx will be 0. 2, 2c, 2 plus 1 is 3. 3 times 2 is 6, so we'll have 6c, which means c will be equal to 4. So this is an easy way to find your ABC. Do you understand? And then let me type some stuff and then we'll move to the next one. Okay, so now let's move to the next one, which is repeated linear factor. So the procedure, partial fraction with repeated linear factors. Suppose the repeated linear factor x minus r to the power of m appear in the denominator of a proper rational function in reduced form. The partial fraction decomposition has a partial fraction for each power of x minus r up to and including the m power. That is the partial fraction decomposition contain the sum. So again, once we start up to the including the mth power. So you have to know if you have to write the partial fraction, you will write a sub 1 divided by x minus r to the power of what? 1. A sub 2 divided by x minus r squared plus, and so on until you have, up to the nth power, where a1 to am are constant to be determined. Like for example, let's do this example so you will see what I mean. We will follow the same step as we did on linear factor, simple linear factor. First thing we have to, you always try to factor the denominator completely. That's the first step all the time. You have to try to factor the denominator completely. So if I check again for this problem, so the denominator is what? I'm going to go a little bit fast because I believe you know how to factor the denominator. The denominator factors as what? We have x cubed minus 2x squared. So we can factor x squared. If you factor x squared, it will left what? X minus 2. So it has one simple linear factor, right? It has one simple linear factor, which is x minus 2. So that is why if I'm writing this one as a partial fraction, so I would have 5x squared minus 3x plus 2 divided by x squared times x minus 2 should be equal to a divided by the first x, which is x to the power of 1, plus this, because this is x squared, right? B divided by again x, then plus now c divided by x minus 2. Okay, so we multiply both sides by what? We multiply both sides by the denominator, the common denominator, which is x squared times x minus 2. If I multiply, let me write. Multiply both sides of the equation by x squared times x minus 2. So if I do that, I will get what? I will leave with 5x squared minus 3x plus 2 should be equal to what? Ax times x minus 2 bx times x minus 2 plus cx squared. So if I factor again, so if I factor everything, I will have my 5x squared minus 3x plus 2 will be equal to what? If I factor x squared, uh, sorry, this was bx squared. This has to be, oh, I mess up. There is no x here because this should be a divided by x plus b divided by x squared. B divided by x squared. So my bad, this happened. I'm going too fast. Always slow down, okay? I found my mistake because I know that should not be true. So is a divided by x, just follow the rule. You see the power is increasing up to what? M. So because this was x squared, so it would have my m is 2 in this case. So a divided by x plus b divided by x squared. That's why. Okay, so now ax times x will be what? Ax squared. So we will have ax squared. I'm trying to factor x squared plus we have cx squared. That's the factor of the squaring term. Now ax times negative 2 is negative 2 ax, so plus negative 2a. B times x is bx, so plus bx, right? And then the other one will be minus 2b. That's what will be left because b times negative 2 is minus 2b. So now we compare. So now compare the coefficients, okay? So if I compare the coefficient, we'll see a plus c will be equal to 5, right? And then negative 2b, I mean negative 2a plus b will be equal to negative 3. And then negative 2b will be equal to 2. So we have three equations again. From the third equation, we can see b will be equal to what? Negative 1. So if b is negative 1, substitute. We substitute negative 1 for b in equation 2. So we will have negative 2a minus 1 is equal to negative 3. Solving for a will get a will be 1. And substitute a is equal to 1 in equation 1. We'll get 1 plus c is equal to 5. So which means c will be equal to 4. Right? So the partial fraction, the partial fraction decomposition will be is we have a, we have b, we have c. So f of x will just be a is 1 divided by x minus 1 divided by x squared plus 4 divided by x minus 2. And that's it. And then we have to find the integral, right? So now, since we have the partial fraction form, then integration now. So to integrate 5x squared minus 3x plus 2 divided by x cubed minus 2x squared dx, it will be the same thing as integrating what? 1 divided by x minus 1 divided by x squared plus 4 divided by x minus 2 dx. So which would be, again, ln of absolute value of x minus ln of and what is 1 divided by x squared, the antiderivative of 1 divided by x squared is, so since it's negative, so the antiderivative of negative 1 divided by x squared, you cannot say that is ln, right? the derivative of 1 divided by x is negative 1 divided by x squared. So the antiderivative would just be plus 1 divided by x, and then plus 4 ln of absolute value of x minus 2 plus c. As I said, you can leave it like this, or if you want, you can write it as you can combine these two. Okay. We also have irreducible quadratic factor. So we have that procedure as well, a procedure partial fraction with simple irreducible quadratic factor. Suppose a simple irreducible factor ax squared plus bx plus c appear in the denominator of a proper rational fraction in reduced form. The partial fraction decomposition contains a term of the form ax plus b divided by ax squared plus bx plus c, where a, b are unknown coefficient to be determined. So this example, let's go ahead and for example evaluate the integral of 7x squared minus 13x plus 13 divided by x minus 2 times x squared minus 2x plus 3. So solution, right? Now note that the quadratic factor is irreducible because we cannot factor this one anymore, right? So I will always try. That's the first thing. You look at the denominator. We have the denominator, which is x minus 2 times x squared minus 2x plus 3. This term is not factorable. We cannot factor this one, so it's not. So the appropriate form for the partial fraction will be, we already have a linear factor. This is a linear factor. We already have a linear factor. So that's why if I'm factoring 7x squared minus 13x plus 13 divided by x minus 2 times x squared minus 2x plus 3, it will be equal to a divided by the linear factor, which is x minus 2. Now plus, this is quadratic, so we will have bx plus c divided by x squared minus 2x plus 3. Same thing now. We are going to multiply both sides by both sides of the equation by the common denominator, which is what? X minus 2 times x squared minus 2x plus 3. Then I will get what? 7x squared minus 13x plus 13 will be equal to a times x squared minus 2x plus 3 plus bx plus c times x minus 2. Okay. So now if I expand this one again, my 7x squared minus 13x plus 13. We know if I factor x squared plus, I will factor the x and then plus, we will factor those who does not have x, the x to the power of 0. So because the highest power is x squared again, right? So we will have a times x squared, we'll have a inside. We have bx times x, so we'll have plus b. So we'll have a plus b. That's the factor of the x, the squaring term. We'll have a times negative 2x, so we'll have negative 2a here. We'll have bx times negative 2, so we'll have negative 2b. We have c times x, so we'll have plus c, right? And then for the constant, we'll have a times 3, which is 3a. And then we have c times negative 2, which is negative 2c. So now we compare the terms on both sides as well by using what? The x power. So we'll see we have x squared, so we'll know a plus b should be equal to 7. Negative 2a minus 2b plus c should be equal to negative 13, and negative 3, positive 3a minus 2c should be equal to 13 as well. So again, I will give you, pause the video, use any method you want to try to find this value a, b, c. So you have a system of linear equation, 1, 2, 3. You can either use substitution, elimination, or use whatever method you want to use it to solve. And then once you solve, so you will see, you will get a is 5, b is b is 2, and c is 1. So which mean to integrate 7x squared minus 13x plus 13 divided by x minus 2 times x squared minus 2x plus 3 dx. It will be what? Finding the integral of 5, open parenthesis for 5 x minus 2 divided by x minus 2 plus, we found b is 2, so 2x plus 1 divided by x squared minus 2x plus 3 dx. So what I'm about to do is, because the first fraction it's easy to find that integral. So I will break it to 2 integral. So this is same thing as integrating 5 divided by x minus 2 dx plus the integral of 2x plus 1 divided by x squared minus 2x plus 3 dx. So the first one, I know I can easily find this one using ln, right? But to find the integral of 2x plus 1 divided by x squared minus 2x plus 3, I have to use substitution. Okay, so the to integrate like just this part, 2x plus 1 divided by x squared minus 2x plus 3. I will use substitution. Let u be equal to x squared minus 2x plus 3. Then du will be what? 2x minus 2 dx. So for this reason, we write the numerator as 2x plus 1 is equal to 2x minus 2 plus 3, okay? Because you see, 2x minus 2 does not appear on the numerator here. So let's write, let's rewrite the numerator, which is 2x plus 1. We are going to rewrite it as 2x minus 2, then plus 3. That's the same thing, right? And then we'll split again the integrand. So, and then split the integral again. This is a little bit long. So, which means I will rewrite again my integral 2x plus 1 divide by x squared minus 2x plus 3 dx. I'm going to rewrite it as the integral of 2x minus 2 divided by x squared minus 2x plus 3 dx plus the integral of 3 divided by x squared minus 2x plus 3 dx. You know, if I combine these two, because same denominator, if I combine negative 2 plus 3 will give me positive 1. So I still have the same thing. So now this will work with my substitution now, right? We said this is u, and then du will be what? 2x minus. But what about this one? Still, we cannot find this. I have to look at my table of integration and then maybe try to make this one a perfect square plus something. And if you look, I'm going to go a little bit fast so you know what we are doing, okay? So this can be rewrite as x minus 1 square plus 2. Okay, so I will have what? 3 divided by x minus 1 square plus 2, which look like what? Look at the tangent inverse integral. So you will see that there. Okay, so that is why since the beginning. So now I'm going to write everything. So I have 3 integral now, right? So first one is 5 divided by what? X minus 2 dx plus, we break down this integral also to 2, so we have 2x minus 2. Let me write this down a little bit so it don't get stuck. So we first had 5 divided by x minus 2 dx, right? Plus, now the integral of 2x minus 2 divided by x squared minus 2x plus 3 dx, then plus the integral of 3 divided by x minus 1 squared plus 2 dx. So we know the first one will be what? 5 ln absolute value of x minus 2. And this is what? 1 divided by u du, right? What is our u? X squared minus 2x plus 3. So this one also will give me ln of absolute value of x squared minus 2x plus 3, right? Plus, now this is, we can take these 3 out. So this is what the inverse trigonometric, you look at the table, that will give me 3 divided by square root of 2, because a is square root of 2 in this case, tangent inverse of x minus 1 divided by square root of 2, and then plus c. And that's it. So I hope you understand this one. So hopefully on the test, you will not have a problem like this, but make sure you understand, okay? I will see you in the next section.